Alright, so let's go over motion graphs like the homework. So, questions that ask, what are the acceleration in the following sections? So looking at a graph like this, we're trying to figure out what the acceleration is. So acceleration, you have to remember from last time, acceleration is final velocity minus initial velocity over time. So if I were to ask, what is the acceleration in step A? We need to figure out what the final velocity is and what the initial velocity is. So looking at section A, the final velocity would be the point at the end of the line segment, which would be 8 meters per second. The final velocity is 8 meters per second. The initial velocity would be the velocity at the beginning of the segment A. So initial velocity would be 0 meters per second. And then we need to figure out the time. The time length of segment A is between 0 seconds to 4 seconds. So it would be 4 minus 0, which is just 4 seconds. Here we can plug it in. So that would be 8 meters per second minus 0 meters per second over 4 seconds. So the acceleration is 2 meters per second squared. You can also look and see that it's increasing 2 meters, so it's gone up by 2 meters in 1 second, another 2 meters in another second, another 2, and another second, and another 2, and another. So let's look at line segment B. B is a flat line. This is a speed or velocity time graph. So straight line implies that B has 0 acceleration. So for section B, it would have 0 meters per second squared. Looking at C. So C, we began at 8 meters per second. So our initial velocity is 8 meters per second. So we began at 8. And then at the very end, our speed was 4. So our final velocity is 4 meters per second. If we look, this was in between 8 and 9. So we have a time difference between 9 seconds and 8. So that's just 1 second. So our acceleration is equal to final velocity minus initial velocity over time. So that would be 8 minus 4 over 1, which would be, my bad, it would be final is 4, so we plug in 4 first, minus 8. So 4 minus 8 is negative 4 meters per second squared. So it decreased by 4 meters in 1 second. 4 meters per second in 1 second. Doing something like D, so D's acceleration. Let's look at our initial velocity. Our initial velocity is at the beginning of the line segment. That's 4 meters per second. And at the very end, we come around and it's D10. Our final velocity is 10 meters per second. And we look at the time. So this starts at 9 seconds up to 15 seconds. So our time would be 15 minus 9, or 6 seconds. So our equation for acceleration is equal to final minus initial over time. So our final was 10, our initial was 4, and it was over 6 seconds. So that would be 6 divided by 6, which would give us 1 meter per second squared. We're taking a meter per second, and we're dividing it by a second. Our unit should be in meters per second squared. If I were to ask you, for example, how far did you travel in line segment B? So how far did you travel in line segment B? So which equation deals with distance? This is how far did you travel is looking for distance. This is a speed time graph, so it doesn't tell us distance. You need to figure out what the equation is. We know that speed, or velocity, is equal to distance over time. You can use your triangle to solve for, so this is speed is equal to distance over time. So, or distance would equal velocity or speed times time. So what is our speed? Our speed during this segment is 8 meters per second. What is our time? Our time goes from 4 to 8 seconds. So our time from 4 to 8 seconds, that's 4 seconds long. So our distance would be equal to 8 meters per second times 4 seconds. So that's 24 meters. So make sure you're paying attention what these numbers mean. These numbers means your speed. And if you have a positive slope, it means you have a positive acceleration. If you have a negative slope, it means your acceleration is negative. By the way, the code word is Charlie. So let's look at this next portion. So remember, the very first step you should be doing is checking what graph this is. So this says D here, so this is a distance time graph. This is a distance time graph. Or distance is in meters, or time is in seconds. Remember that for graphs in which it's distance versus time, acceleration is going to be curved. So if we have a curved segment where it's not straight, that would be your acceleration. So the segment from B to C, that's a segment, B to C, so this point to that point is positive acceleration, and from D to E is negative acceleration. And as long as you're moving upward, your distance is getting bigger and bigger, you're moving away from the starting location. And whenever your distance is going back down to 0, you're moving closer toward it. Another thing I should note is that instantaneous velocity and average velocity only equal whenever you have a straight line. So if you're accelerating, your speed is constantly changing. So your instantaneous speed, the speed at any given point, is constantly changing. If you wanted to calculate the velocity, so for example, what is the velocity of the line segment FG? So what is the velocity of line segment FG? So remember that speed is equal to distance over time. So what distance did they travel? So at F, at this point here, you went from 40 meters to 10 meters. So you decrease by 30 meters. So you put in your initial distance, or your final distance first. So you went from 10 minus 40. So you went and changed your distance by negative 30. And you did this for between 50 seconds and 60 seconds. So between 60 and 50. So you did it for 10 seconds. So your speed is negative 3 meters per second. It's the same thing as doing slope. The slope of this line is going to be your speed. If you remember back to whenever you did slopes in your math classes, you look and you take your y2 minus your y1 and divide it by your x2 minus x1. This is what your slope is equal to. Your slope for a distance time graph is going to be the same thing as your speed. So speed is equal to the slope. So we take our y2, this point right here. So this is x2 comma y2. And this point right here is x1 comma y1. So our y2 value is 10, or y1 value is 40, or x2 is 60, and our x1 value is 40. And this gives you an answer of negative 30. This is supposed to be 50. Your x1 is 50. So negative 30 over 10, this gives you negative 3, and your units would be meters per second. For a velocity time graph, the slope is your acceleration. So write that down. For distance time graphs, slope equals speed. And slope is equal to y2 minus y1 divided by x2 divided by minus x1. For velocity time graphs, or speed time graphs, slope equals acceleration. I hope that helps you guys. That's it for today.